Hey everyone, grade 4. Our section today is about graphic solution of linear programming problems. The first example, find the optimal solution for the following linear programming using graphical method. Our objective function is maximize z equal 10x1 plus 40x2. We here see two constraints. The first constraint x1 plus 2x2 less than or equal 100. Constraint 2 x1 plus 5x2 less than or equal 150, and non-negative constraint x1 and x2 greater than or equal 0. So the strategy to solve this type of problems as follows. To solve it in graphical method. The first, transfer all the restrictions to equation. What is mean? Every inequalities should be transferred or convert to equalities. So the first constraint is equal x1 plus 2x2 less than or equal 100. It will be x1 plus 2x2 equal 100. The same procedure we will do with the constraint 2. The constraint 2 here is x1 plus 5x2 less than or equal 150. It will be x1 plus 5x2 equal 150 instead of less than or equal 150. This is the step 1. Step 2, determine of 2 points for each constraint or straight. So we have here straight 1 and straight 2. Straight 1, we create this table or solve in any way. When x1 equals 0, x2 will be equal 50. How? When x1 in this constraint 1 equals 0, so 2x2 equal 100. So x2 equal 100 divided by 2 equal 50. So when x1 equals 0, x2 equal 50. In the same constraint, when x2 equals 0, so x1 equal 100. When x2 equals 0, so x1 will equal 100. 2 multiply multiply 0 equals 0. So x1 equal 100. So the straight one, when x1 equals 0, x2 equal 50. When x2 equals 0, x1 equal 100. This is for straight 1 or constraint 1. For the constraint or straight 2, when x1 equals 0, x2 equal 150 divided by 5, it will be equal 30. So the first point is equal 0 and 30. The same we do with x2. When x2 equal 0, x1 will be equal 150. So the straight 2, when x1 equals 0, x2 equals 30. When x2 equal 0, x1 will equal 150. This is the step 2, determine of 2 points for each straight. So the first step, transfer all the restrictions or inequalities to equalities as follows. Second step, determine of 2 points for each constraint or straight as we do. So we can now draw straight 1 or constraint 1 and constraint 2. The constraint or straight 1, the first point is equal 0 and 50. 0, 0 here and 50 here. This is the first. second point for constraint 1, when x2 equals 0, x2 equals 0, x1 will equal 100. So the second point, when x2 equals 0, x1 will equal 100. So the first constraint here we can draw as follows. We can match or connect the 2 points as follows in straight 1. The same we will do with constraint or straight 2. When x1 equals 0, x2 equals 30. So x1 equals 0, x2 will equal 30. When x2 equals 0, x1 equal 150. 150 here. So we can match between 30 and 150 in this shape. So the joint solution, it will be A and this region A, D, C, B, or A, B, C, D. Why? Because the constraint 1 and constraint 2 is less than x1 plus x2 less than 100, and constraint 2 x1 plus 5x2 less than or equal 150. So this is the visible solution, or this is the joint solution. So we select between A and B and C and D the maximum point that will achieve the maximum profit. So the maximum point here, it will be C, because D and A and B once x1 or x2 will be equal 0. So it's not solution. The solution is to maximize both of A and x as both of x1 and x2. So the extreme point here is point C. It is the interaction between the straight 1 and straight 2. Straight 1, x1 plus 2x2 equal 100. Straight 2, x1 plus 5x2 equal 150. Using calculator, we can determine that x1 equal 66.7 and x2 equal 16.67. Or we can solve it by mathematical. We can multiply the first constraint minus 1, so minus x1. Here is positive x1. We will remove both of them together, or we can say x1 equal 100 minus 2x2 and substitute the first equation in the second, so x1 plus 5. We can say x1 equal 100 minus 2x2. So x2 here, x1 here, it will be 100 minus 2x2 plus 5x2 equal 150, and we can solve it in easy way. So the x1 will be x equal 66 and x2 will be equal 16. So we can substitute those values in the main objective. So z equal 10x1 plus 40x2, it will be 16.7 multiply 40 plus 66.7 multiplied by 10, so the result will be 1335. So we can produce 67 from chairs and 17 from tables to achieve the profit 1335 in those constraints in the current constraint of production. This is for the example 1. Example 2, find the optimal solution by using graphical method. The objective function is equal z equal 12x1 plus 14x2 subject to 4, 1, 2, 3, 4 constraint. The first constraint 2x1 plus 3x2 less than or equal 24. Constraint 2 2x1 plus x2 1x2 less than or equal 16. Third constraint x1 less than or equal 7. For the fourth x2 less than or equal 6. As we solved before, the first step to transfer all the restrictions to the equation, or we can say we can convert all the inequalities to equalities. So the first constraint or the first state will be 2x1 plus 3x2 equal 24. The second constraint will be 2x1 plus x2 equal 16. Third state x1 equal 7. The fourth state it will be x2 equal 6. Second step, determine of 2 points for each state. So the first state 2x1 plus 3x2 equal 24. So when x1 will be 0, so x2 will be 8. 3x2 equal 24, so x2 will be 24 divided by 3, it will be 8. When x2 equals 0, when x2 equals 0, so the x1 will be 12. How? X1 will be equal 24 divided by 2, so it will be equal 12. Straight to 2x1 plus x2 equal 16. So when x1 equals 0, so the x2 will be equal 16. When x2 equals 0, x1 will equal 8, and the straight 3 here is x1 equal 7, so is equal 7. x2 equal 6, so the constraint will equal x2 equal 6. There is no 2 points here. So we can draw the linear programming as follows. The first constraint, when x1 equals 0, x2 equal 8, 0 and 8, 0 and 8, and x1 to x2 when 0, x2 equals 0, x1 equal 12. Here is 12. So we can connect both of them, 8 and 12, to draw the first line or the first constraint. Second constraint, 0 and 16, x1 0 and 16, 0 and 16, and 0, x2 equals 0 and x1 equal 8, 0 and 8. So we can draw this the second constraint. So the second constraint we will connect 16 and 8 on x1. Third constraint, x1 equal 7, x1 equal 7, x1 equal 7 here. Fourth constraint, x2 equal 6, so we can here 6 and draw this line. So we draw all the constraints. So the solution or the joint solution, this region. How? Because is the first constraint and second constraint and the third and the fourth constraint is less than. So the joint solution or visible region that will achieve all of those constraints, this area. We can say this area is A, B, C, D, E, F. So the extreme point in this area, it will be C, D, and E. C, D, and E. We can choose this point F or A or B, because one of x or x1 or x2 will be equal 0. So the most points that will achieve the maximized profit, it will be E or D or C. E or D or C. Point E is interaction of straight 1 and straight 4. Point E here is interaction between this constraint 1 and constraint 4. E here or x2 equal here is 6. So when x2 is equal 6, we can solve equal as follows: 2x1 plus 3x equal 24. So x2 when x2 equals 6, x1 will be 3. So again, when x2 equals 6, so 2x1 plus 3x2 equal 24, it will be 2x1 plus 3 multiplied by 6 equal 24. So the x2, when x2 equals 6, it will be x1 equal 3. As follows, we will do with point D, is interaction between straight 1 and straight 2. D is interaction between straight 1 and straight 2. So we can say straight 1 is 2x1 plus 3x2 equal 24. Straight 2 is equal 2x1 plus x2 equal 16. So we can solve it as we know. So x1 equal 6 and x2 equal 4. Again, we will do with point C, is interaction between straight 2 and 3 and straight 3. Point E, point E, D, E, point C, yes. Point C is interaction between the straight 3 and straight 2. Here is interaction between straight 3 and straight 2. So straight 3 is equal x1 equal 7 and straight 2 2x1 plus x2 equal 16. So x1 will be equal 7 and x2 will be equal 2. So we will substitute each points. For example, point E, when x1 equal 3 and x2 equal 6, and the objective function. So the objective function will be z equal 6 multiplied by 14 plus 3 multiplied by 12. The result will be 120. Point D, when x1 equals 6 and x2 equal 4, the objective function will be z equal 4 multiplied by 14 plus 6 multiplied by 12 equal 128. Point C, when x1 equals 7 and x2 equal 2, the objective function will be 2 multiplied by 14 plus 7 multiplied by 12. The objective function will be 112. So the maximum value it will be when when the interaction or the point D. The point D it will be achieve the most result, or is the best point to achieve our goal, to achieve or maximize the profit. So we can reduce 6 books and 4 draw to achieve a return of 128.